All right, class, so today I wanted to go over problem number 22. This was from homework 1. I got a couple people inquiring about it, and so I thought I'd dive a little bit deeper into especially this supply and demand problem and what supply and demand problems are. Remember that the final project for this course is to pick a chapter you really like and dive into one subject a little bit deeper, and I just figured supply and demand would be a really good thing to do a final project on. So I've also posted a couple more resources on supply and demand problems for you guys. So let's get started. So let's talk about a supply curve. So when I have a graph, I'm going to put quantity on my horizontal x-axis and price on my vertical y-axis, right? And so a supply curve is the relationship between P and Q from a manufacturer's point of view, right? I'm the one who's making the product. That's what I mean by commodity, right? It could be baseballs, it could be erasers, it could be paper clips. I don't know. I'm not very creative today. But as the manufacturer, the greater the quantity I have to supply, the higher the price to me, right? The higher the cost to me. So a supply curve is always going to have a positive slope, okay? So that's our supply curve. When we're talking about the demand curve, so the demand curve is the price a commodity sells for related to the quantity available, right? The supply curve puts Q as our quantity still on our horizontal axis and our price is still on our vertical axis. But the demand curve is from the consumer's point of view, right? So the price is going to be greater. Let's say that's like 100, 1,000. This isn't a very scaled graph. Sorry, guys. Okay, from 100, 200, 300. Okay? So as the quantity goes up, like as the demand decreases, if there's more of them out there, people are going to pay less for them. So I saw this happen during this pandemic, right? I'm not sure if you guys heard, but there was a toilet paper shortage, right? So the price of toilet paper shot up. So did the cost of hand sanitizer. So did the cost of masks, right? That's because there were less available. We were over here. The price was higher, okay? Now we've fixed some of the supply chain things, thank you manufacturers, and so the price has gone back down, okay? So the demand curve is always going to have a negative slope, right? It falls from right to left. The price goes down as the amount out there increases. One thing that's really neat is when I look at the intersection of supply and demand, right, they're going to have an intersection point. And this is called the equilibrium point, right? This is when the quantity produced and the price is stabilized, right? This is what me as a manufacturer and me as a consumer wants. It's what's best for us so that the price stabilizes. I don't want to go to the store and have toilet paper cost $10 one day and $100 the next day. It did not get that high. But we like to have a price equilibrium, okay? So I want to find the intersection of this system to find the equilibrium. Now, problem 22, this was on page 36? Yes, page 36, this was homework 1. It said, consider the following 4 equations. So I have these 4 equations right here, and one of them is the supply curve, and the other one is the demand curve, but it doesn't tell me which. And I need to identify the 2 equations and find the intersection point of those 2 curves. So first, let's use the information that we have. So the first thing I know is that a supply curve is going to have positive slope. So which 2 of these equations could be my supply curve? Well, it's going to be this one and this one. So the top 2 with positive slope, those are my possible supply curves. I also know that the demand slope is, the slope of a demand curve is going to be negative. So that would be these 2 right here, right? These are my possible demand curves. So here I have my 2 possible supply curves, and my two possible demand curves. Now I'm trying to find a point of intersection for them. So what I'm going to do is I'm going to need to play around, right? One way we solve systems of equations like this is by setting our equations equal to each other. So let's take a look at our first supply curve. So I have my supply curve and I have my two demand curves. I'm going to set my supply curve equal to each of my demand curves and see what happens. So bear with me for a second, gang. So if I have my supply curve, 0.01 q minus 5, which is equal to p, and my demand curve, negative 0.01 q minus 10, which is equal to p, I can go ahead and solve this. And the first thing I need to do is I need to combine like terms. So I'm going to combine my variables first. So by combining my variables first, I get 0.02q minus 5 equals negative 10. Now I need to combine like terms. So I'm going to add 5 to both sides. So I have 0.02q equals negative 5. Now is there a problem here? Well, let's go ahead and solve. That gives me q equals negative 500 because I divided both sides by 0.02. So that's my quantity. So can I make a negative quantity? No, one thing we didn't talk about when we're looking at our supply-demand curve, it starts at 0 and it's always positive. Okay, so my quantity and my price can never be negative. Can you hear that thunder? It is raining cats and dogs. Okay, so now that we know that our quantity and price can never be negative, let's check our supply curve again with equation 2. Why don't I change colors? Because let's keep it festive. So now I have 0.01 q minus 5 equals negative 0.01 q plus 5. I add my variables to combine like terms. I get 0.02 q minus 5 equals 5. And then I add 5 to both sides, and I get 0.02 q equals 10. And I divide both sides by 0.02, and I get q equals 500. Okay, this is great. It seems like we are doing everything correctly. I've solved for q. So I need to plug that back in to my supply curve in order to solve for p. So I just solved that q equals 500. And I need to make myself some more room, so I did that. And now I can plug that back in. I need to solve for p, right? We're trying to find the point of intersection. But p equals 0.01 times q minus 5. So if I plug that in, 0.01 times 500 minus 5, that gives me p equals 5 minus 5, which is p equals 0. Can that happen? So if I produce 500 and that's the quantity I have available, then I'm going to charge absolutely nothing for a product? No. So aside from p and q not being negative, p and q cannot equal 0. So with this equation, we got a negative q. With this demand curve, we got a price of 0. So that means that this could not be our supply curve. So p equals 0.01 q minus 5 is not, I repeat, is not the supply curve. So let's go back to the original problem. I had 2 possible supply curves and 2 possible demand curves. Using the process of elimination, we have eliminated our first supply curve. Next, what I need to do is I need to check the second supply curve with our 2 demand curves. Excuse me. So I have supply curve p equals 0.05 q plus 0.5, and I need to set it equal to each of these demand curves. So I have 0.005 q plus 0.5 equals negative 0.01 q minus 10. So I'm going to go ahead and add 0.01 q to both sides. That leaves me with 0.015 q plus 0.5 equals negative 10. If I subtract 0.5 from both sides, that gives me 0.015 equals negative 10.5. And I need to go ahead and divide both sides by 0.015. Now hopefully by now you've seen the problem. I get Q equals negative 70. This breaks a rule, right? A rule that Q can never be negative. All right, so that means that this is not our demand curve. I'm going to go ahead and clear the room. Give me some more space. Let's go ahead and try our second demand curve because this one got canceled. So now I have my supply curve plus this demand curve here using our deductive skills. And I need to go ahead and solve for Q. So I'm going to go ahead and add 0.01 to both sides. That gives me 0.015 Q plus 0.5 equals 5. I subtract 0.5. I get 0.015 Q equals 4.5. And I divide both sides by 0.015 Q. Nope, not Q, just 0.015. I want this Q to be left by itself, so I get Q equals 300. That seems like a good quantity, right? Well, first thing I need to do is check it back in to either of these equations in order to check the price. So P equals 0.005 Q plus 0.5. So if I have P equals 0.005 times my Q, which is 300, remember we're substituting in order to solve for P, I get P equals 1.5 plus 0.5. So P equals 2. In this case, it's $2, right? So our price, our point where we reach an equilibrium is when the price is 2 and the quantity available is 300. And there's our lovely solution. So feel free to reach out to me with any questions. Supply and demand curves could be one of the topics for your final project. Something to keep in mind as you are working through the chapters. If you guys ever need additional resources, please reach out to me. That's what I'm here for. And I hope you enjoy the rest of your day. I will reach out again soon. Bye.